It seems nowadays that everyone knows about two definite things. One, that the mitochondria is the powerhouse of the cell, and two, that there are these dark, massive balls of matter in space that nothing can escape from, even light. These are called black holes.
But how are these stellar vacuum cleaners formed? For one thing, they aren't really the vacuums of space. If we were to crunch our sun into the size of a black hole, we would still be orbiting it and wouldn't get sucked in. Yes, gravity is strong in a black hole, but only when you get really, really close to it. Also, black holes are not circular, but rather spherical, just like any other star in the universe. They compose of three main parts: the accretion disk. It's like the black hole is bathing in the matter of the stars it slowly takes in. The event horizon, the point of no return, and the singularity. And we don't know what happens to the matter after this point. Or do laws of physics even apply?
Now, black hole happens when a star 3 to 15 times the mass of our sun starts to run out of fuel. Although this will never happen to our sun, if we were to make it into a black hole, it would just be 3 kilometers in diameter. I think it's time to explain what a black hole really is. Black hole is a region in space that can't be directly observed because information cannot escape from it. However, it can be observed due to the swirling matter around it.
Just like how water doesn't directly enter a drain, but rather swirls around before entering it, black holes follow the same principle, and this swirl of gas and dust is from torn up stars that were a little too adventurous. This is called the accretion disk. Black holes have an edge to what you can see, and this is the event horizon or the Schwarzschild radius, calculated by the formula 2gm over c squared. It's ironical, really, that the darkest object in the universe is surrounded by so much matter and heat that for an observer far, far away, this light would almost be blinding.
When nearing a black hole, time slows down. Imagine this cloth as space-time. When I put light objects on it, space and time bend around it. Even though they don't bend too much, for something to get from point A to point B, it's going to take longer. The same would go for a high mass object. Now imagine these magnets as a black hole. They're a small object but with a very high mass. The magnets bend the fabric of time so much that for an observer outside, he would see you falling into the black hole really, really slow. But for you, time would remain the same. And just before your body becomes a string of atoms entering the singularity, you're going to see the life of the universe flash before you. You see, it's all relative, as said by Einstein.
All good things must come to an end. Black holes die due to something called the Hawking radiation, named after Stephen Hawking. It has been theorized that virtual particles come into existence and quickly annihilate each other throughout the universe. However, if these virtual particles are formed everywhere, some must form on the edges of these event horizons. So as the pair is formed, one might spiral into the black hole, and one is emitted as radiation called the Hawking particle. Now you might ask, if nothing can escape the black hole, how is this radiation emitted? Well, because it really isn't from the black hole. When the negative particle of the pair enters the black hole, to an outside observer, it looks like the black hole just lost mass and got a little smaller.
So when you hear that the Large Hadron Collider could potentially create a black hole, don't worry because it won't last very long. And this radiation will make it quickly dissipate away before it does anything to our planet Earth. Black holes have got a reputation of being the bullies of space. However, unlike supernovae from normal stars or gamma ray bursts from neutron stars, black holes are relatively calm and we actually owe our existence to them. The most popularized theory as of now is that at the center of our galaxy, in fact most spiral galaxies, there is a supermassive black hole, millions or even billions of solar masses. If it wasn't for this cosmic glue, matter would have never come close enough for our solar system to form. A solar system that we now call our home.